Hey there, my name is Alejandro, and welcome back for day 11 of me doing the NeetCode 150 challenge. So today we're doing our very first trees problem. Let's get straight into it. Okay, problem 226, invert binary tree. LeetCode easy. Given the root of a binary tree, invert the tree and return its root. What does invert mean? If I remember correctly, best to learn by example. So here we have 4, 2, 1, 3, 7, 6, 9. So 4 had 2 in its left, 7 in its left, 7 here and 2 here. And then 7 used to have 6 on the left and 9 on the right, but now 9 is on the left and this used to, so just like a reverse linked list, this was like one of the two like very famous like meme problems of LeetCode, like oh, can you even reverse a linked list, bro, or can you even invert a binary tree and so on. Like I think this was like a few years ago, back in 2021, but let's do this problem officially on this channel. So okay, invert binary tree, essentially it's like, okay, this is going to be very easy to solve recursively. Is there any follow-ups or anything? No. Okay, the number of nodes in the trees in the range 0 to 100 and so on. Okay, so the way we can do this is essentially we recognize that we want the 4's left, so the root's left subtree is now going to be the right subtree, right? And the old right subtree will now be the left. But we'll see that just doing that is not enough. We can try that. So first of all, we'll do if not root, then return root or none. It doesn't really matter. Or we might as well return root. It's the same thing. So if root is none, then just return none. Otherwise, essentially, so we have a root, right? And so we want to swap the left and the right, right? So we can do something like root.left, root.right is equal to root.right, root.left, right? And then this would be like return root. But here's the problem. This will actually not work. Right, so it'll work in these cases where, so the root is like at most two levels in total, right? And this one, and the last one is just empty, right? So this solution will work for for trees that are up to a depth of or a height of 2, right? So it's like no nodes is equal to a height of 0, 1 node is equal to a node of 1, and up to 3 nodes is equal to a height of 2. Anything more than 3 nodes will fail, right? So in this case, for example, and the reason being that if we just swap the left and right subtrees, well, we'll have the 7 here, but this 7 had 6 and 9 as its like left and right subtrees here, right? But we really wanted to have 9 on the left and 6 on the right. So what we need to do is apply this idea recursively, right? So we swap the left and the right, and then for each of these subtrees, we're also going to invert them, right? So it's like the left and right subtrees of those are going to get swapped, and recursively for those, like have their lefts and rights swapped. So essentially, here we can get away with a little bit of Python magic. So this, by the way, is the equivalent of doing something like, so if you're not using a language like Python, you might have to do something like temp is equal to root.left is equal to root.right, and then root.right is equal to temp, right? And then instead of this, right? And then it's like, then you would return root and so on. In Python, it's just kind of nice because you can just do swappings in this very way right here, right? So I'll just comment this out for now. But the idea, okay, let's do it like this. The point here is that we're not gonna be able to, we need to apply this idea recursively, right? So once we have swapped the two trees, we need to apply this function recursively. So here we're gonna do self.invert tree of root.right and self.invert tree of root.left, and then return root. So does something like this work? It does. Let's submit it. And there you go. It works perfectly, better than 66% and so on. And in case you're not used to this syntax, this is how you would do it otherwise, right? So we have like temp. So we can even make this a clear, like temporary of left. So root.left is now equal to root.right. We can even do something like this, right? So root.left is equal to self.invert tree of root.left, and then root.right is equal to self.invert tree of root.right, right? Apply these functions recursively and then swap them together, right? So root.left, root.right is now equal to root.right, root.left, right? And here we would return root, right? With the rest being commented out here, right? And so something like this, I would expect still to work as well. Right, so, and here we just submit. And the point is that we apply this idea recursively, right? Or even if I put this up here right before these calls right here, this would I expect to still work as well. Right, so this works. and submit, and so on. And maybe this one is the most straightforward one to understand, right? Okay, so here it's just a little bit slower and so on, but again, you kind of get the point. It might not even be slower, it just might be that we got a bit unlucky. So let's resubmit it and so on. Okay, it is technically a little bit slower and so on, but the idea is essentially this. The point is that you're going to have a root node like 4 here, right? You're going to swap the two subtrees around here. And then for each of those subtrees, you need to apply this idea recursively. So you recursively call the same self.invert tree function to have all those subtrees also quote unquote inverted, right? Because again, it's not sufficient to just swap the left and right childs of the root nodes. For both the left and right child, those trees also need to be inverted even after the swapping even happened, right? So it doesn't matter which way that you do this. We can also probably write this in one line just to be like, you know, the cool guy. Return root if not root, else oh, actually we probably can't do it, right? If not root, return none. Otherwise, yeah, we can't really do it in one line. But yeah, otherwise we can just do things this way. And there we go. Bada bing, bada boom. So let's just submit this one more time. And there we go. Okay, 99.8%. Wow, so close to 100, but so close, but no cigar. Okay, as always, I always do a little quick recap of how I was able to solve the problem for each of the problems that I solve. In this case, again, the idea is very much the same. Essentially, you want to invert this binary tree. Inverting means that like you swap the left and the right children, but also that these children also get inverted as trees, right? So, like for example, you'll notice something like 7 has a left subtree with this 6 node here, and the right subtree with a 9 here, right? And it used to be on the right of 4. Now it is on the left of 4, but also this subtree itself was inverted, right? Because 6 used to be the left of 7, and now 6 is the right of 7, and 9 used to be the right of 7, and now it is the left of 7, right? So here the idea is essentially you take a root node like 4, you're going to swap the left and the right, and then recursively call the invert tree function on both of those nodes, right? So again, like you're going to swap the left and the right like this. Root dot right is comma root dot left, right? Or another way you can do it is of course with the temp left and so on and but Python just allows you to quickly do swappings like this very nice and efficiently. But again, just swapping the left and right children is not enough. You must also say, okay, root dot left is now equal to its inverted version of itself, right? So root dot left and root dot right is equal to self.invert tree of root dot right? And then if I submit something like this, this should again still work, right? So this is essentially the underlying core idea behind this algorithm. So essentially like swap the left and the right, and then with these newly swapped left and right children, these subtrees need to also be inverted themselves. So recall the invert tree function on them with that left or right child as the root of that new subtree, right? And so that's essentially the way that you solve this problem. But again, we can all do those 3 lines of code with just 1 line here, resubmit this again, and so on, bada bing, bada boom, right? So the point is that for something like this, you'll notice that the root dot left here is essentially the root dot right subtree inverted, right? And then for the root dot right, it now becomes the root dot left subtree, but again with the recursive invert tree function applied to it. And that's pretty much it for this solution. So I hope that explanation made sense. As always, let's just check off the fact that we did this problem. So now we're at problem 11 out of 150 of the NeetCode 150 problems, which feels very, very nice. But otherwise, that's pretty much it for this video. I hope that you found it useful and enjoyable. And if you did, I would highly appreciate if you left a like or a comment. And otherwise, I'll catch you in the next one. And until then, ciao, ciao, my friend. Bye-bye.